To be blind is not miserable. Not to be able to bear blindness, that is miserable. John Milton wrote that. More than 285 million people currently live with visual impairment. For many of these cases, there is no cure. Yet, in recent years, there have been breakthroughs in our understanding and treatment of blindness. Sanford Greenberg lost his vision to glaucoma at the age of 19. He is currently chairman of the Board of Governors of Johns Hopkins Wilmer Eye Institute. He joins me today to talk about his experience and his mission to end blindness. Also joining me, an extraordinary group of scientists: Bennett of the University of Pennsylvania, Schwartz of the Jules Stein Eye Institute, Eberhart Zrenner of the University of Tübingen, and Carla Shatz of Stanford University School of Medicine, and once again, Kandel, a Nobel laureate, a professor at Columbia, and a Howard Hughes medical investigator. I began, as I always do, with my friend Eric to give me a big overview of our subject tonight. Eric?
Charlie, the last program we did was on new approaches to the treatment of deafness. Tonight, we're going to consider new approaches to the treatment of blindness. As is the case with deafness, blindness is not a life-threatening situation, but it's tremendously disabling. And in some ways, it's more disabling than deafness because, as you pointed out, there are a number of very important blindness conditions for which there is no treatment. Now, why is that so? Unlike deafness, the sensory organ for vision, the retina, which is evident on the lower image, which shows the eye, the retina lines the inside surface of the eye. That is the most complex sense organ that we have. In fact, it's not a peripheral organ. It's actually a part of the central nervous system. It's an extension of the central nervous system. And as a result, it has the complexity of central nervous system structure. Moreover, it's not uniform. It has a small area in the center that is clear on that image, which is called the macula. The macula is the area of greatest visual acuity. So if I focus in on you, I turn my head toward you, my eyes focus on you, and the macula really analyzes your features. Unfortunately, the cells of the macula are extremely sensitive to damage that leads to blindness. And so this is a really serious problem. And we, at the moment, have no treatment for that, even though this is a point of great visual acuity. Blindness, as you indicated, is a range of conditions. It ranges from complete blindness to partial blindness. Complete blindness means that you don't see images, you don't see figures, you don't see people. You can't tell the difference between day and night. This is Sandy's condition. A partial blindness varies from having tunnel vision to having cloudy vision to having night blindness. Now, you can have difficulty with vision from two sources. One is if you have a damage to the visual pathway that goes from the retina into the brain, and Carla will discuss that more. But we are not going to focus in on that as a source of blindness. We're going to limit ourselves to disorders of the retina. And, you know, as you indicated, there are close to 300 million people worldwide that have various degrees of visual impairment. And these fall into two categories: treatable diseases and, at the moment, things that are essentially untreatable. So cataracts, glaucoma, and diabetic retinopathy are treatable diseases. With cataracts, you have cloudy vision. With glaucoma, you have tunnel vision. Diabetic retinopathy, you have difficulty with night vision. What I find tragic is that still there are a number of people who suffer from these conditions, and this is a graph only of the developed world, the United States, Canada, Europe, because these are eminently treatable conditions. In the case of diabetic retinopathy, these are preventable diseases. And in the underdeveloped world, these are major forces of blindness, and that's because people don't have access to medical care, and that's an absolute tragedy. In the developed world, the major problem is macular degeneration. And as we indicated, there's a form that accounts for most of it called dry macular degeneration, which is really a sort of an age-related disorder in which people really lose a lot of their vision, their visual acuity. And in the past, the only thing you could do for people like that is to give them non-visual guides. teach them how to read Braille, a seeing eye dog, handrails in their apartment, and speech compression devices of the kind that Sandy developed, which makes it easier for them to handle auditory information. But recently, this has changed. We are sitting here in the midst of a revolution in the treatment of macular degeneration, and it opens up treatment of many kinds of blindness. That is because three major developments have occurred: gene therapy, stem cell therapy, and retinal chips.